Tailings dams are among the largest engineered structures in the world. Most mines produce much larger quantities of waste and tailings than economic minerals. Tailings typically include ground-up rock, processed water, and chemical reagents, a potentially hazardous slurry that must be contained safely. If a tailings dam fails, the consequences can be disastrous for communities and the surrounding environment. Globally, there is a need for improved risk management around tailings dams. Risk management is typically focused on the engineered structure, but the surrounding social, environmental, and economic context also has a bearing on disaster risk. We encourage mining companies, governments, and local communities to work together to create a complete picture of tailings dams and disaster risk. This presentation focuses on risk factors that should be considered. We started with a sample of around 1,900 active metalliferous mines listed in the S&P database, and then refined this to 532 mature mines that predate the mining boom of 1999 and the early 2000s. Through a series of tests, we identified that 328 of these mine sites have wet tailings with high water content. Next, we analysed these 328 sites against a framework of 8 environmental, social and governance indicators, or ESG for short. This framework draws on multiple global indexes and datasets and focuses on the context in which these tailings dams operate. The environmental risk context contains the 2 primary indicators, waste and water, that cover external natural factors which greatly affect tailings dam failures. Waste addresses topographic ruggedness, erosion, and instability, and it also covers seismic activity in the local region. Water considers rainfall events and regional flooding. While waste and water are the 2 most obvious indicators, there are 6 secondary indicators that need to be considered as well. Biodiversity also sits within the environmental context and covers vulnerable ecosystems and regional ecological stability. The social risk context houses 3 indicators. Land uses provides an understanding of agricultural and population density neighbouring the mining project precinct. Indigenous peoples evaluate the proximity of lands managed or owned by Indigenous people. This can be an indicator of potential marginalisation or even dispossession. Social vulnerability explores a variety of demographic indicators, including poverty and other social inequalities. The governance risk context contains the last 2 indicators. Political fragility considers the political and institutional impact on the governance of the mined resources. Approval and permitting explores national and regional regulatory processes and evaluates how these have been applied to large-scale mining projects. These 8 environmental, social and governance risk indicators were applied to the 328 sites. 55 facilities were identified with multiple and high ESG risks. Then we did further localised analysis. The proximity of watercourses can magnify the impact of tailings dam failure. They channeled the inundation along a defined corridor that will often be inhabited or used by people. A spatial analysis of streams in proximity to each of the mines revealed that all 55 mines were within 5 kilometres of a watercourse. And through other tests, we were able to identify that 33 of the facilities have human settlements nearby. What this approach enables us to do is to connect the facility with its operating context, and it provides better optics over the inherent or situated risks that exist around tailings dams. It helps us to think about the implications for managing these facilities and for the safety and welfare of people who live close by. This approach provides a model for assessing risk beyond the mining facility and orientates our thinking to the host context. Further research is required to refine the application of the ESG framework. Eventually, we would like to automate some of the analysis. We would also like to develop more granular indicators for local context vulnerability. In the meantime, we are working to apply the approach to a more current sample of facilities. A free copy of the research article used to create this presentation can be downloaded by following the link in the description. Please contact us for further information.